So hi everyone, welcome to the our very first JuiceFS Office Hour. So the Office Hour is a
Right,
session in
actually, wait a minute.
sessions
Wait a
to
minute.
JuiceFS team is placed to change ideas and these real world scenarios of using JuiceFS cloud file system. There's a quick housekeeping here. So please drop your questions anytime at chat, and we will start with the ones submitted in advance, and then take live questions. And please say hi in the chat and tell us where you are coming from, and keep your questions brief so we could get to as many as we could. And since this is our first session, I'd love to hear from your feedback. So make sure you fill out the questionnaires attached to the chat, and basically tell us what's work and what you want to hear next time. And for today's agenda, we will have our co-founder Ray Su to introduce the JuiceFS file system, and then we can go straight to the live Q&A session. So without further ado, let's welcome our co-founder Ray Su. It's all yours.
Hi. Hi. Hello. Hello, everyone. Good afternoon. Let me share my screen. Oh, yeah. Okay. Okay. Next 50 minutes, let me talk about JuiceFS Overview. Hi, everyone. Welcome to our very first JuiceFS Office Hour. And I'm Rui Su, co-founder of JuiceFS. Uh, and Over the next 50 minutes, I'll share the journey we've taken 7 years of license, benchmarks, architecture, and design principle. Uh, then we'll open the floor for live Q&A. So get your question ready. Let me start with a quick overview of JuiceFS. The cloud service was first launched in 2017, and since then we'll keep iterating and search for product market fit. And in 2021, we released the open source community edition, and just a few years, it has grown rapidly. Today, the community edition has over 12,000 stars on GitHub, and from the data we can track, there are already about 15,000 volumes in use. And also, our cloud service has also reached about 15,000 volumes. The most common use case in AI, from the autonomous driving, generative AI to quantitative research and biotech. So many teams use JuiceFS as a unified storage for both AI workloads and their data lake, and it's also widely adopted as Kubernetes persistent volumes. Yeah, and in the bottom right of this slide, you can see a chart from the OSS Insight website. Yeah, it shows that JuiceFS, even as the youngest project, has already surpassed quite a few others and is right behind Ceph. But why we built JuiceFS back to almost 10 years ago? We live in a world where we can spin up 1,000 cores or even GPU in seconds, and bill per minute keep getting lower. But sometimes on our dashboard, we can see exactly like this: computer nodes idling, waiting on I/O or tiny metadata cores. The moral is simple: the raw CPU is no longer the bottleneck. Data access semantics are the new bottleneck. So I'll give you two examples. The first is a real story from one of your user. Yeah, it's the first story from MemVerge. It's a company building software for bioinformatics workloads. Uh, what you are seeing here is RNA sequencing pipeline that run in the cloud to keep costs down. They use EC2 spot instance for compute, S3 for storage, and mount it into cluster with S3FS. In this chart, the red bar represents failed tasks. Yeah, after auditing, the root cause was clear. The workload has generated huge number of tiny files, many less than 1 kilobyte. Each small write through S3FS painfully slow, and many simply timeout. After switching from S3FS to JuiceFS, you can see the field tasks are gone. And if you compare the total runtime of the pipeline, you will notice a clear improvement. Yeah, with the S3FS, the job took 26 hours, but with JuiceFS, it's finished in just 7 hours. Yeah, it's about the same runtime you get with AWS EFS. So no longer wasting a massive amount of CPU time just waiting on I/O. That's exactly the kind of bottleneck JuiceFS was designed to remove. This, the second example comes from the talk at Spark Summit 2020. Yeah, given by engineering team at Pinterest. They share they shared their journey migrating from HDFS to S3. On paper, the two systems offer very similar throughput. Uh, so the expectation was that job would perform about the same, but in practice, we saw dramatically slowed down. The root cause wasn't bandwidth, it's metadata performance, especially operation like a move, yeah, which very cheap on HDFS, but become very expensive on object storage. In some of their Spark streaming job, the single difference caused runtime to stretch out to more than 4 times slower compared to HDFS. This case highlights the same thing. When metadata is slow, no amount of raw storage throughput can save you compute from stalling. Yeah, this slide is show us very simple benchmark where we compare S3FIs, AWEFIs, and the JuiceFS. And we only tested sequential raise, and rise. But you can already see JuiceFS demonstrates strong concurrency. Throughput scale up as you add more POSIX and more clients. Yeah, uh, I don't dive deeper into performance today. It's a very rich topic. But if you interested, you can find more details in JuiceFS documents. We also submit the results to MLPerf this year. That's an industry standard benchmark for evaluating storage and AI workloads. The results were just published, and we'll cover them in future office hour. Yeah, and beyond performance, why do we care so much about being POSIX compatible? Yeah, because you say the pipeline in real world are very messy. 1 minute you are in batch script, next minute you need to feed in Spark and maybe FFmpeg, maybe PyTorch. So what do those tools share? They expect a POSIX file system because all of them speak files. So POSIX API are the lingua franca. Object store are 5 static blocks, but when you try running ls-l on a dictionary with 10 million objects, or rename our output folder, and you can wait seconds, minutes, even longer. Those list and rename latency break the workflow and yeah, maybe push team to rewrite perfectly good tooling. And in practice, we did the stuff at POSIX. We also made JuiceFS compatible with S3, HDFS, WebDAV, and more API and protocol. So it's much easier to connect with different applications. The design of JuiceFS has been widely recognized by all users, from GenAI service, agentic applications, to the GPU cloud provider, as well as leader in autonomous driving and biotechnologies. Yeah, so next I'll walk you through a few case stage in evolution of JuiceFS and share the architecture ideas and the design choice behind each stage. Yeah. Uh, Back to 2014 and 2016, our founder and CEO, well, S3 bottleneck firsthand, well, he is building deep breaks. Yeah, S3 was amazing for durability, but terrible for shuffle and even append. That frustration planted the seed. Could we design a cloud-native file system that looks like POSIX to every two? And meanwhile, every distributed file system you could name include HDFS, SFFS Lustre, was designed for bare metal cluster, not for the cloud. You had to sit on top of EBS, which very expensive, and you still couldn't take advantage of a real benefit of a cloud service, elastic on-demand provisioning, and fully managed infrastructure. Oh, and yes, around 2016, AWS did introduce EFS. It's a elastic file system that seems to solve the problem, uh, but at roughly 10 times cost of S3. Even worse, if EFS throughput scale linearly with the amount of data you store, so compute-intensive job with small data size face a brutal choice. Run painfully slow and with the expensive CPU, or pad file system with dummy data uh, just by performance. Neither option was acceptable. So we keep looking for a better answer, and just became JuiceFS. So when we started up, we set three design goals. The first is keep metadata completely separate from bulk data, so each layer can scale or fill over on its own. Need more directory lookups, add metadata nodes, and need more row throughput and object store bandwidth. So two concerns that don't fit each other. A second goal is store the actual file blocks on object store. We trust is cheap, scalable, and durable by design. At the same time, by using the local disk on computer nodes as the uh, cache, we can significantly boost the data performance. The third last one is the stay in user space with Fuse. Uh, it's giving us one binary that mounts on any kernel container, even some serverless runner, no patches required. And between 2018 to 2020, we show early builds to everyone who's listened. The surprise is strange far beyond the big data ETL and analytics. Uh, Machine learning, scientific HPC, VFX rendering, CI/CD, backup, uh, database, and more scenarios with very different I/O patterns. And each domain optimizes a different corner of capacity, performance, and a cost triangle. We realized no single vendor could be a silver bullet, even a startup. So we introduced open source edition. It's not a pivot, but as a complement to proprietary build. The goal was give developers an open framework could expand, debug, and even rethink a design framework and the mindset framework. So in the next slide, I'll show you exactly how it play out in practice. Yeah, in January 2021, we pushed version 0.1 to GitHub and GPL under GPL v3. Yeah, it's only spoke Redis for metadata. It's very extremely basic. I know you remember architecture from a previous slide. The metadata service in JuiceFS start out as our own customer build distributed system, and now we switch it to Redis. Everyone knows well. But before we dive into that, what happened next? It was remembering the landscape. Virtually every distributed file system that came before uh, CFFS, HDFS, Lustre, DGFS, GlusterFS, MooseFS, and more was architected for bare metal cluster, not for cloud. So JuiceFS was to all knowledge, the first file system designed from day one to export public cloud building blocks. Object storage for durable data, uh, pluggable database for metadata, and ephemeral compute for catching and the scale out. Yeah, we also made a clear promise to community edition. Yeah, first is the simplicity and the cost efficiency. You only need one command to deploy. Minimum babysitting, price like a S3 plus a small metadata store. Is good enough for most workloads. And second is the uh, open design framework. You are invited to extend the swap components and even rethink parts of the stacks. It's both a working file system and a living blueprint. So even the version 0.1 only spoke Redis for metadata, that's transparent cloud-first architecture resonated. Developers spending cloning, benchmarking, fitting issues, and crucially submitting pull requests within days. I remember we stood on the front page of Hacker News and the GitHub trading page. Yeah, the early validation told us the problem was real, and the community energy confirmed we are on the right track. Uh, Fast forward 12 months, we shipped the first GA release and flagged the license to Apache 2.0. Deliberately more permissive choice. Yeah, the openness let us keep adding new front ends, thinking on S3 compatible API or language specific SDK on top of a POSIX core. Yeah, without introduce legal friction. It's also removed the copyright anxiety. In the same release, we made a metadata full pluggable. Uh, yeah, you can see Redis, MySQL, PostgreSQL, TechAV, Foundation DB, you name it. Yeah, all right, folks. I know it's been a lot of information, so let me quick recap the key points. Uh, and first, JuiceFS is a distributed file system designed from the ground up for the cloud. It works on any cloud. Second, it's fully POSIX compatible, and on top of that, it also speaks S3 and HDFS API and protocol. Third, it delivers very strong performance aggregation across multi-clients. And finally, Compared with other solutions we know of today, JuiceFS offers outstanding cost efficiency. It's the big picture I want you walk away with. So up to this point, we will walk through the background how JuiceFS was developed, some of the lessons we learned along the way, and the design ideas we put into practice. Yeah, if this has sparked yourself, the quickest way is to influence this project to start repo. Here is the GitHub link and the file issue, or better yet, send a pull request or doc update. Yeah, we merge doc as eagerly as code. We also love to have you join our Slack channel for more discussion. If you already have questions, feel free to drop them in Slack now. Yeah, we have our office hour channel. Uh, and we'll bring them into the lab session. And of course, you can scan this QR to follow us on LinkedIn and X. So now it's your turn. Drop question in chat, and let's begin. But last, don't forget to subscribe our YouTube channel. Yeah, thanks for listening.
Well, thank you very much, Su. So now we are in the live Q&A session. So please submit your question in the channels. You can either put it in Slack or in the live chat of the YouTube channel, and also probably comment on our X or LinkedIn account. Okay, I have a question coming in. Is from Brian, Brian Model. So the question is, do you have tips for how to optimize JuiceFS for a single monitor? In particular, how to configure cache optimization to avoid any cache invalidation? So if we're gonna take that question.
Oh yeah, sure.
In particular, how to configure cache optimally to avoid any cache invalidation.
Yeah.
Well, in JuiceFS, we have several cache-related parameters. One of them, I think the most important one, is the cache size option. So you need a large enough local disk for cache storage. And then you just set a proper cache size. When we do eviction, I mean cache eviction, it would be because of insufficient storage. So we don't have particular or special tips for preventing cache validation. Just use a larger storage. And when we do evict data, they would be carried out in a sort of a strategy more or less like LRU, least recent used. But in practice, we just pick two random blocks and then evict the one that's accessed earlier, right? So in most of the real world scenarios, it would behave like LRU. Okay. I think that's all. That's my
Yeah, I think also we have actually multi-tier of cache systems. So you have local cache and the remote share cache, right? So the remote cache is exclusively to that particular client, and then you can have the remote cache, which can be like a cache group and serving the cache through multiple cache group numbers. So if you have a fast networking, and you can considering have this multi-tier of cache, then you can speed up your cache performance. Particularly if you want to cache all of the data, you want to to achieve high performance, you may considering as using the remote cache. We can normally have a much large capacity comparing to your local cache.
Yes.
So is that answer your question, Brian? If you can hear us, could you put in the chat? Yeah.
Yeah, and I suggest before you optimize your cache configuration, I suggest you run JuiceFS states to observe the performance of your mount point. Maybe you could update you some parameter like buffer size and max upload, max download to improve your mount points performance. Uh, yeah, and then maybe the second step is optimize your cache configuration. Uh,
Okay.
yeah, and Qing, maybe could you introduce our new colleague on the stage?
Oh yeah, sure. This is
Uh,
our chief operation hand. So he's very experienced. To support like companies across the world, literally, right? So we have customer in Berlin, in Iceland, usually North Asia, and then in Middle East. So literally, so that's you can see his hair is because he's working really hard. So welcome, Eve. Let's wait for the next question. Yeah. So you are still seeing the object traffic. So yeah. So basically, you can. I think maybe you can maybe we can take the offline. There's the channels where we can in. Then we can look in more debug information. Not just the states command. We can look at the if there's an eviction happen in the cache and other factors in there. So if you could join our Slack channel, and we can have someone contact with you, and we can do the further debugging of that issue. All right. Oh, thank you. Thank you for joining us. So this again is a monthly event. We try to fix like the day for every month, but it depends on the holidays and other. And yeah, so this is our first session for the office hour. So make sure you fill the feedback after the session, so we know what we're doing good and what we want to hear from our next session. Okay, so here comes another question from Jack. Does anyone successfully use JuiceFS with what is it name? BurgerDB as a metadata? Okay, Kubernetes and its drive we switch from port to sidecar. So if you here?
Yes. Unfortunately, I mainly do enterprise edition tech support, so I'm not extremely familiar with the community version. But I do think, Surey, do you know if any of our community users are using BadgerDB as a metadata engine?
Yeah. As I know, MariaDB uh, uh, is a local database like SQLite. So I'm not sure it could be working on Kubernetes environments. Yeah.
Right. Oh yeah. So considering it's a local database, you mean it's more or less like SQLite, I suppose.
Yeah, I think it's not suitable for multi nodes to share your volume.
Well, so it must inherently not a good fit for Kubernetes use. Um, if you were to adopt it in Kubernetes, you will have to create sort of a shared storage just for this BadgerDB. Um, I imagine it could cause problems. So
So if you only have a very small divide to manage, could you try, sorry, could you try etcd? As it is building in your Kubernetes and we support etcd and the metadata engine. Uh, But in your experience, etcd is only work for a small data size, maybe less than million files.
and he also mentioned that switching to the sidecar mount mode to avoid single write conflicts. Does this mean um, BadgerDB does not support uh, parallel writes? I'm not.
Yeah, it's essentially I think this two parts question. It's does the Kubernetes using RCS driver using the mount mode will have this single writer conflict? I don't think so. It's like we in the metadata side we just to avoid that conflict because we all need to talk to the metadata to actually to write or read from actual the data over there. So I think the second part of the question probably doesn't exist, but if we could using the metadata using the backup DB as the metadata engine, that's questionable because I haven't ever seen any customers using that. Nobody that's using Redux and SQL Server or SQLite, that sort of metadata engine. Yeah.
Oh, so the sidecar question wasn't related to the use of BadgerDB as metadata engine. Am I correct?
Yeah, that's what I think so. Right? It doesn't matter that the sidecar, CS driver doesn't really relating to the engine you're using the meta to host the meta, right?
Yes. Okay, so
So for this question, I think offline we're gonna to try to run the BagoDB as the metadata and let if it's like feasible to doing that. Yeah, and okay. So please again join our Slack channel and then we can contend with you and maybe sync with you the findings, or you can post the issue, or in our GitHub repo. Then we can have some conversation over there. Okay. Oh, thank you. Welcome to our office hour, the very first one. Okay, let's get this live in under 5 or 10 minutes to see if there's any other questions coming in. And then we're gonna conclude in this our very first office hour.
Oh. Mm.
Okay, now it's 5:44 PT. This concludes our first JuiceFS Office Hours. So thank you everyone to join us. Make sure you fill out the feedback form. And see you guys in the next office hour. Thank you. Bye-bye.
Thank you, everyone.